So based upon the classification of the analog to digital converters, and now we are going to see the flash type analog to digital converter, which is also called as simultaneous type analog to digital converter. So this simultaneous type of analog to digital converter is based on comparing an unknown analog input voltage with a set of reference voltages. So in order to convert an analog signal into the digital signal, we require some n number of output bits, so which can be represented as a 2 power n minus 1 number of comparators are required. So for example, here it is shown for a 2-bit analog to digital converter that requires 3 comparators, which is nothing but 2 to the power of 2 minus 1, which is 2 square is 4, 4 minus 1 is 3 comparators are shown for a 2-bit flash or simultaneous type of ADC. So which means by this we can calculate how many comparators will be required for a 3-bit flash ADC, so which is going to be 7 comparators. So 3 op-amps are used here as comparators. As you can see, these are the 3 op-amps which are used as the comparators that is connected to the analog inputs, and all the 3 comparators are connected to the analog input voltage. The inverting terminal of the op-amp is connected to the set of reference voltages. So these are the reference voltages, and this is the analog input which is connected. So the reference voltages are named as 1 by 4V, 2 by 4V, and 3 by 4V respectively. Okay, and then they are connected and the voltage is being obtained, or the power supply is being connected through an potential divider network. So the output of the comparator is in positive saturation stage when the voltage at the non-inverting terminal is more than the voltage at the inverting terminal, and it is in negative saturation state otherwise. So when an analog input voltage is less than this 1 by 4V, the voltage at the non-inverting terminals of the 3 comparators is less than their respective inverting input voltages. So this is what I told. So the inverting input voltages, which are so and so, and this is a comparator table with the digital outputs and the comparator output. So here we have given some of the input conditions for the input voltages ranging from 0 to V by 4, V by 4 to 2 V by 4, and 2 V by 4 to 3 V by 4. And based upon that, we have written the comparator output values, and therefore we have obtained the digital outputs also. So when you consider the first condition where you have the analog input voltage as less than this V by 4, in this case what happens is the voltage at the non-inverting terminals of the 3 comparator is less than the respective voltages at the input inverting terminals. So the comparator outputs are going to be 0, 0, 0. So this is what I told you. So the comparator outputs are applied to the further coding circuit. So this is the further coding circuit in order to get the digital outputs. And this is an example of a 3-bit A to D converter, a flash type. So I have told already, for a 3-bit flash type A to D converter, we require 2 power 3 minus 1. So which is 8 minus 1, 7 comparators are there in the circuit. So this flash ADC is also called as an parallel A to D converter. And this has got an encoder circuit with it. So this is going responsible for producing the binary output. And finally, it is the advantages and disadvantages. So simultaneous type of, that is the flash type of ADC, is the fastest because the A to D conversion is performed simultaneously because we have a set of comparators. So through this we can obtain a faster conversion, and hence it is called as the simultaneous or a flash type ADC. So typical conversion time is you can name it in like 100 nanoseconds or even lesser than that. And also the next advantage is the construction is very simple, which means it is easy to design. And then coming to the disadvantages, the simultaneous type of ADC is not suitable for A to D conversion with more than 3 or 4 digital inputs. Then 2 power n minus 1 comparators are required for an n bit A to D converter, and the number of comparators required doubles at each added bit size. So, so this is the disadvantage where it requires more and more. So this is the disadvantage where it requires more number of comparator circuits for when you are going to increase the size of an ADC. So that's all about flash type of ADC, and thank you.